So we're going to have two presentations today, and what I wanted to start with, who am I? I'm a semi-retired CTO, and I've also done lots of things, but my expertise mostly in regulated industries, and I've done a lot of work in machine learning and whatnot, and I'm also now kind of a nerd in the whole .NET, C#, Maui, Blazor type things. I have a couple of software patents in the area of personally identifiable information for companies working at scale, and I'm currently helping startups in town here. That's my focus. I love startups, right? Wherever I can to help them sort of get to first base and maybe beyond. So one thing I'd like to do is if any of you have something that you'd like to speak to, I'm more than happy to help you get that pulled together and give you a space here where you can kind of talk to people about what you're doing. So you can grab this code, and that'll give me my LinkedIn, and you can just join and we can have a chat about that. Okay. So first talk, prompt engineering. Starts with a question, right? That's what prompt engineering is, asking good questions. So we're going to talk about how you can go beyond just asking a good question to have the service do a lot more for you than it would otherwise do. Because when you hear the term prompt engineering, people really don't know what it is because it's a relatively new art, okay? And I thought it would be interesting for everybody here to have a chance to kind of internalize that term prompt engineering. Now, if you are a prompt engineer, this presentation might be useful to you in learning how to tell other people what it is. If you are on the other side, if you're a business stakeholder wondering if prompt engineering can do anything useful for you, then I'm trying to answer that question. So what is a prompt? Well, you know, it's a question that we ask in ChatTPT. I'm sure everybody here has used ChatTPT. You type in a question and you get back an answer. Prompt engineering is really a collection of techniques and tools that allow you to extend the capabilities of that process. So let's talk about a prompt. Retrieve our current marketing plan, create a summary, and send it to my team. There's a whole lot baked into that, right? How could it do that? Well, with prompt engineering, you can actually make this return something useful. So prompt engineering, you've got a prompt, it comes in, you got an app that's been made to integrate with a back-end AI service, doing either text completion or chat completion, and then return that, and you say, hey, we're not just returning the result to the ask Sarah, hey, Nancy and Fran are getting copies too. How in the hell do we do that? Magic, right? So there's challenges here that we address with prompt engineering. The first is where to find my current marketing plan. So your system has to know that you have marketing plans and where they are and which marketing plan belongs to Sarah. And who are my team members? Well, again, the system needs to know that Sarah has 2 team members, right? And then finally, how do I send emails? Like, you know, I can return text, but how do I send an email? So these are all examples of the challenges that we can address with prompt engineering. Any questions so far? By the way, if anybody has a question through it, just raise your hand, wave at me or whatever. Any questions so far? Yes?
Can you go back like one slide, or maybe it's 2? Okay, prompt engineering support, are there any frameworks that do that?
Yes, I'm going to demonstrate one today. Well, I'm not going to actually demonstrate, I'm going to speak to one.
Okay, cool.
Yeah, and there are loads. I'm just picking one. Prompt result. Well, this is what we wanted to see. Sarah, here's your summary of the marketing plan you requested, and I've emailed the summary to Nancy and Fran. Nancy, Sarah asked me to send you, did it? Hey, that's cool. 3 emails with different content personalized for each person. All right, how do we do this magic? Well, I'm going to use an analogy. Most people have had a brush with art, even if it was just grade school. I am no artist. My daughter is an artist. My brother and sister are artists. I didn't get that gene. But one of the things that I know, having people in my family that really are into the art community, is that there's a big difference between a novice, a competent artist, a professional artist, and a master. And the definitions there are interesting. Just really briefly, in the art world, a novice is someone who's learned basic techniques, right? Okay, they know how to use a brush, they know how to draw, they know how to do some really basic stuff with color. But a competent artist is an expert on color theory and all sorts of other perspective, proportions, all sorts of things. A professional is somebody who takes all that competency and knows how to monetize it. So they know how to talk to other people and collaborate on ideas and deliver a product that they can that the customer can use in some way. And the master is somebody who's transcendent. They take it to the next level and do something you didn't expect with those tools. Well, let's talk about that in juxtaposition to a prompt engineer. So we have a novice, competent, professional. What do those things mean? Well, I'm going to try to explain that a little bit. First of all, novice. All you need to have to be a novice prompt engineer is language skills. You already have them. You know how to ask a question. You're already a novice prompt engineer. However, when you move to a competent prompt engineer, you need some advanced skills. You need to have establishing sufficient context to get the things done that you want to get done. You need to know a bunch of things about tooling and how it integrates with the rest of your technical stacks. There's a lot of stuff that goes on beyond just being able to ask a good question. And then finally, a professional is someone who can take all those skills and, like the artist, have conversations and collaborate with stakeholders to deliver something of value, okay, in the business process. And master, same thing. Transcendences are those folks that are inventing this stuff behind the scenes, coming up with unexpected, cool stuff, right? ChatTPT was transcendent. Nobody thought it was going to do what it did until it did it, and then everybody was like, "Wow, that's pretty cool." So why do prompt engineering? Well, a novice artist, I'm going to give you another analogy here. Is a novice artist could take a color, paint by color, and fill it in. And the result might very well be indistinguishable or very close to what the competent artist who did the outline would have done. So that's an example of somebody taking something that's already, in large part done and just filling in the blanks. Prompt engineering is a lot like that. So with a prompt engineer, a novice prompt engineer, and I said you guys are all novices, right? You could take that and paint by color and end up with a prompt response that is really doing something spectacular. ChatTPT. It's basically a piece of paper and a box of crayons. It's only so far you can go. You can do a lot of cool stuff, but it's only so far. You need additional tools to go further than that. So again, you're already a prompt engineer. You have a question? No? Okay. And just to reiterate, it's because your existing language skills. This is why ChatGPT has been so successful. You're already all trained to use it. There's no bar. You just sit down and start typing in questions. And if you don't already know how to set context, do things like that, you intuit it along the way. You learn how to do it, right? So it's leveraging what people already know, and that's an important aspect of it. So let's talk about a typical application. What does that mean? It means that we've got in the cloud somewhere, we've got a service running, and then you've got a client that calls an API, an application programming interface, maybe a REST API, something like that. It turns around and calls some app services. The app service probably turn around and maybe read and write to the database, and then returns a response, right? Of course, it gets a lot more complicated, but the basic idea is that you got somebody making a request that goes through the stack. This is called the stack, and it returns a response. Almost every sort of business application out there in some form looks a lot like this. Hey, here's the same thing, but with a simple prompt flow. It doesn't mean it replaces. This would be more an add-on to the previous. So we have an AI SDK of some kind that knows how to orchestrate. It knows how to make calls to AI services, like OpenAI or one of your favorite. And now we get a prompt coming in. It's still a request, but we're going to call it prompt here to be very specific. And it's going to do all this stuff here necessary to connect to, authenticate with, and make the call into the AI service to get a response back that can then be returned to the caller. Not too complicated, right? Well, this part is interesting. This is something we have to install in our stack. Well, that's probably not something that most people... Do you want me to move that?
I'm just going to take it.
Okay, no problem. So anyway, this is where you would need somebody with programming skills to install these tools. Now let's get a little more exciting. What does an AI SDK do? Well, it calls things called plugins. This is a generic term. It was sort of invented by and promoted by OpenAI, the company behind ChatGPT. And basically, it is something that will, it's some functionality that you can plug into your environment. And if you have a whole bunch of plugins, then you could orchestrate them to do multi-step processes in one, right? So remember our coloring book? Plug into the coloring book. It basically is a wrapper. It takes some small input from the user and fleshes it out into something much bigger, much more sort of valuable. Okay, so what, go. I don't know why I did that. Okay, so plugin, what are the elements of a plugin? Well, we've got, the 5 things here that you would find. First of all, we have semantic functions. Fancy word. All it means is that we're taking a prompt and we're maybe templatizing it and we're passing in some keywords, and then we're going to take that prompt and we're going to send it off to the AI service and we're going to get a result back. So it's basically the same thing you would do if you were sitting at a keyboard and typing. So it's either pre-processing or even post-processing the prompt so that you maximize the value that it either on the way in or the way out. Native functions. Well, a native function would be like, hey, send an email. It's not semantic, that's just calling a system function. Lots of other things could be provided. Function pipelines, that's just lining up a bunch of these functions in order. And I'll show you that in a minute. And then context snippets. Context snippets are probably the most powerful piece of this whole puzzle. When you use ChatGPT, you often have to say, like if I was asking a programming question, I say, okay, I'm using .NET, I'm using CSharp, I have this language snippet, talk to me about it. If I just put the language snippet in, it would have to guess what language, and it might have guessed Java instead of C# or something like that. So you establish a context that limits its response to something relevant to your query, right? So you can actually think of a whole bunch of contextual elements, I call them snippets, and put them in a database and then retrieve them and use them in fabricating your queries that you then send off. So the semantic functions might use one or more context snippets to establish a context that the LLM can use to give you a better response. Okay, and then finally planners. Planners are cool. Planners say, hey, if you have a whole bunch of plugins, if you give me a good description of each of those plugins, and you just say you want to do something, I can look through all your plugins and I can use natural language, I can use my language processing skills to pick which of those plugins I should probably try to organize into some sort of plan to get the goal that you're asking for done. That's a planner. This stuff exists, it's very cool. So we'll talk about that. So semantic function, again, it's got some input, some context history, and some options. So these are constructing the best query you could possibly construct prompt to send to the LLM. Native functions, send email, we talked about. Write, save a document to disk somewhere, call an application service or a microservice. Pre-process the inputs, right? Post-process it. Maybe you get a JSON document back from the LLM and you want to push it through a tool to make sure that JSON document is well formed. Maybe even fix it up a little bit. Okay, and then finally, basically anything you want to do that you need to do, it's available in the system, including inventing stuff on your own. So it can be as business specific as domain, sort of vertical market specific as necessary. Questions so far? Yeah. Okay, next one, function pipelines. Let's say that I have a plugin like the one we talked about earlier, hey, I want a marketing plan summarized. Hey, native function retrieve the marketing campaign. The semantic plugin to summarize it. And then a native function to send the emails out to the team. So we're starting to see how we might decompose that big prompt that it wasn't big in terms of number of word count, but it was a big idea, it was a big ask, right? Break it down into, easy bits. How do you eat an elephant? One bite at a time, right? So that's kind of what we're doing here. Context snippet references. So again, you have a whole bunch of these context snippets that you can reference and bring in to reuse in your semantic functions. You can also use it to take some of the limitations that are baked into most LLM models and make them less onerous. For instance, even with ChatGPT version 4, there's like a 8,000 token limit to what you can send to it. Tokens are not words, but close to it, just for this argument. So you say, well, geez, maybe I've got 20,000 words or 100,000 words in a document. How can I establish a context? What you could do is maybe break that document down into chunks. And you could summarize, have the LLM summarize each of those chunks. And now, if you add up all your summaries together, you're underneath that 8,000 token limit. It's 8,196, but who cares? So the idea is that you can take the larger body of information that you have, you break it down into smaller chunks through summarization, and you can then pass that into as part of your prompts. What I've found is most real-life engineering efforts are context-centric, meaning that as soon as you start trying to apply prompt engineering to a business need, it's all about the context. So planners, what are planners? Well, remember I talked about plugins, right? We can have a database of plugins, and if each of those plugins had a nice little description like retrieve marketing plan, summarize marketing plan, send email to my team. Now, these aren't functions, they're plugins, so we took it up one level, and we registered them in a database of plugins. And with these descriptions, what your LLM can do is it can say, hey, you want me to retrieve a marketing plan. I got a plugin that says it knows how to do that. Hey, I want to summarize, I know how to do that. Especially with the marketing plan, I know how to do it in a special way. And hey, I want to send email to my team. So now a planner can take your prompt and it can say, hey, let's look at the available plugins and find which ones would actually be useful in achieving this goal that you've stated in your originating prompt, and we'll just string them all together for you. So, and unlike the pipeline before where it's like, okay, I'm going to do this one thing and I'm always going to do it in the same way, you can have a bunch of these plugins that can be shuffled around, mixed and matched for different goals. You might like plug in, send an email to my team could be used in all sorts of different contexts, not just this one use case we've talked about. Yes?
And just so that I understand correctly, plugins in this perspective are just like services, right? Like microservices that you can call that generate a result.
I wouldn't call them microservices.
Or a service.
In the very most general sense, yes. But a plugin is a technical definition as well. It is basically a piece of functionality that has a RESTful interface and which has sort of an API of its own that the other system can use to elegantly and quickly shuffle them around and reuse them. So high level of reusability through a consistent interface. Microservices don't fall in that category. Yes?
Yeah, I just, from a developer perspective, plugins, when we have our ADE like Eclipse or Jeopardy, a plugin is actually a feature. You get a plugin to use VI, and I think technically it's an extension of a class, right? So the framework has some capability.
In the loosest sense possible, I don't know why they chose the term plugin, but yes. In fact,
it goes with the framework support system.
Yeah, in other words, it has to conform to the hosting application's plugin API. Right? So you can write a plugin for Visual Code or a lot of other products. And so what it means is you can create, as the author of, say, the hosting environment, Visual Code, for instance, you can say, hey, you want to write a plugin that knows how to do this, that, and the other thing? Here's our API. OpenAI has a plugin store.
Cool.
So you can write plugins or be a consumer of plugins that other people have written. That is cool, right? And so Microsoft and OpenAI have really gone down that route.
A very excellent graphing and visualization plugin, actually.
There you go.
You can literally just upload a CSV file and ChatGPT will go through it and it'll produce like graphs and summaries with the CSV file for you. It's very nice.
So did that answer your question? I wasn't.
Yeah.
You're good. Okay. But I really want to make the point here that this is orchestrating planners, plugins, not functions. Plugins contain functions. So in a previous example, instead of a big plugin that does that very predetermined steps of 3 functions, we could wrap each of those functions in separate plugins and surface them so a planner could use them. So what if you want to support loads of plugins and lots of context? You stick it in databases. So a plugin database is basically a collection of plugins that the AI SDK can read and say, oh, okay, I have all these plugins I can use. So that's basically, there's a key and there's descriptions and the planners can use all that, but you can also go get them by key and bring them in and use them inside your own predetermined flows. Context snippets are basically, an encoded, I don't know if I want to get way deep in encoding, but when you take text and it's going to be consumed by an LLM, you don't just give the LLM text. That's not the way it works. Instead, you go through the text and you encode it. And you encode it both for consistency, so words that mean the same thing are just one token after you've encoded it. and also for space savings because they encoded files often a lot smaller because these are just numbers. Every word becomes a number. And there's like 72,000 words in the codex used by GPT-4. There's like 50,000 in GPT 3.5. So that means that when it goes through text, every element of that text that's tokenized is associated with that number, okay? And we have a vector, array of those numbers. That's called an embedding. All right, that's all the technical stuff. We can move on. The idea for somebody who's doing prompt engineering is I got a whole bunch of predetermined, pre-encoded textual information that I can use for my semantic functions to help establish context to achieve, even more grandiose things than I would otherwise. It also, as we mentioned, lets you get past that barrier of the number of tokens.
I think it's too much. That would be the query vector, not the embedding. The embedding comes from the query vector.
Well, actually, what you can do is you can take the embeddings and concatenate them and then put it in the prompt query. So I think we're talking about the same thing, right?
Yeah, I think so.
Okay. So I'm going to talk about the Microsoft Semantic Kernel AI SDK. It's so their SDK is called the Semantic Kernel. It's available in CSharp and Python. This is that piece that sits on the server in the back end. So you could have a server stack that's running .NET, or you could have a service stack running anything and use Python. So either way. I believe they're working on one for Java too, but it doesn't matter. So how do you develop semantic functions? Not plugins, functions. Well, this is the kind of thing that you would want people to be able to do at their desktop in a simple, straightforward way. So what they have is a Visual Code. Everybody probably familiar with Visual Code. It's an editor that Microsoft developed. It's written in Python. It's extremely popular. It's a really easy use tool, and it's got lots of extensibility. So they wrote a plugin extension to Visual Code that's supportive of the semantic kernel. And what it does is it runs the semantic kernel locally, and it can make calls to your AI service like OpenAI. And it can use a local file that defines a semantic function. So you can literally right there in real time play with it until the semantic function works the way you want. In addition, you can actually have a local embedding database, which context snippets, which is there's a whole bunch of different vector databases supported. Some depends on whether you're working in Python or C#. You can do either with Visual Code, obviously. So this allows you to develop the semantic functions, which you then are going to push up into your plugin library and actually into the plugin. I'll go back all the way here. So a plugin, one of the pieces is semantic functions. So that Visual Studio Code extension that they provide lets you build these guys. This stuff, this stuff, this stuff, and this stuff are all stuff you have to, well, the planners are kind of already baked, you just use them. But these three you have to develop using regular programming techniques. So, before I go into my summary, I want to stop and ask questions. Anybody like totally bemused, want me to go back and cover a slide, or is there something, why didn't you talk about? Question?
Maybe later, I don't want to get derailed.
No, I think the whole
How's the job, any idea on job opportunities for this kind of stuff?
exploding. Yeah, exploding. If you think about what this means from a CTO perspective or an architect, you're always looking for ways that you can deliver more value to your customers. Like maybe they're in-house, or your development team is the production engine. You've got product managers saying, I want the deal chicks that always need to be fed. And so the faster you can feed them, the fatter they get, the sooner they're not bothering you anymore, right? So you can look at it as a way to deliver more quickly. The other thing too is that a lot of companies are prone to the shiny new toy syndrome. Yes, what does that mean? It means, oh, my buddy Joe on the golf course told me about this thing called semantic kernel or prompt engineering, or they throw some words out they don't understand, and they say, we need that. And you go, yes sir. And you go build it. And luckily, this is one that actually can add real value, unlike some of the shiny new toys in the past. Yes.
Sorry, I think I've heard it called FOMO, fear of missing out. Like, oh, I'm going to miss out on this. Some executive. One thing is, maybe you can help direct us. I'm in AT&T as a consultant, right? And we're doing all their physical switches all over the country.
Yeah, sure.
And there's tons of what are our documentation
perfect example where you would
And
use
then
this.
my upper level manager, hey, you better get this set up because the guys over that work in the executives,
Uh-huh.
they want to turn this Confluence loose on some AI stuff so people can go in and just ask
Yeah.
the questions.
Yeah.
Now, I'm a low-level programmer guy, but I want to figure out, while I'm doing my job there, how do I ramp up on these kind of skills so I can go be a consultant and then sell services like this?
Mhm. Actually, that's a fabulous example. I'll give you another one that's similar. My wife works for the state of Nevada as a caseworker, and they have literally thousands and thousands of pages of legal interpretation, not just the regulations, but the interpretation of the regulations, the interpretation of the interpretation of the. And at the end of the day, their job is to make sure that they provide all of the proper services to the people they're working with. And so they have to take all these interpretations and apply them. Guess what changes every week? The interpretations, right? Or the new rules, or whatever. So one of the things that would be really great, just like with all this Confluence documentation, if you were able to make it easy to find the information you need out of all that documentation quickly, which you guys are already doing with ChatGPT in the broader sense of the internet, right? Why not do it on a collection of documents that's specific to your business? That's where that context snippet library comes in. So they call it auto training and a bunch of other auto tuning and whatnot. But you can actually extend and then focus the attention of the LLM to your particular product subject matter, whatever it might be, and then make that a valuable resource to your team, whether it be fixing jet engines or, finding stuff about switches or whatever. Yeah. Sir, go ahead.
Yes, all those stuff looks great, but it brings obstacles like enterprise a lot. After right now is security. Can you?
I didn't hear that. I'm sorry. Speak up a little bit.
Can you talk about a little bit on the security?
Oh yeah, sure. Security is a big. I have not talked about security here at all. Did we lose it? That's odd, isn't it? Try it again. It was blinking. I guess it's dead. Oh, is that what happened? Thank you. That's excellent. Okay, so security. My background is in fintech and casino and other and investing management. So I've had a lot of regulatory burdens that I've had to address over the years. All the usual rules apply, which means that people who sit down and build applications with prompt engineering and the AI stuff, they don't have a get out of jail free card. They have to comply with all of the regulatory mandates already in place for whatever sort of business they're in. If they're in the fintech industry, it's a stack that high. I mean, there's a lot of stuff you have to know. Casinos are highly regulated, investment management highly regulated, healthcare, which I've never done, is even worse, I think. Working with the government and defense, my son's done a lot of that, very heavy regulatory burden. So what you need to do is understand those things and then ask the question, as you develop and field these features, am I going to be compliant? It's not like there are any new security ramifications of this. All the old rules apply. And the problem with any new technology is that it's often written by people who don't know what the strictures are. I'll give you an example. In the fintech world, it is almost impossible to use Node.js. Wait a minute, everybody uses Node.js. No, they don't, because when you use Node.js and you start bringing in all those libraries, not the language, it's all the libraries. You get thousands of libraries. Every single library used in the financial institution application needs to be audited. It needs to be certified for use. Even if you do that once for Herculean tasks, what happens next time you do an update? Do you have to do it all over again? You've got thousands of these open source libraries written by people who are dragging in libraries that they barely know. And suddenly it's all on you as the agent behind making sure this audit can happen to make that, oh no. But if you use something like C# or maybe some of the Java-based frameworks and libraries, all those libraries are already certified. They are known good quantities. They change more slowly, and you can use them with confidence. Yeah.
Yeah, I'm seeing a lot of that. I did consulting with insurance companies.
It's the same thing. They're highly regulated. Yeah.
Compliance, and I never seen in the last 15 years of software development things slow down so much because even Java libraries, they don't pass the security test, and then it's like.
I said, yeah. When I said Java, I said a little less than, but like the gold standard It's probably C# right now, the .NET libraries, yeah. And the reason is, think about it, Microsoft is the largest software manufacturer in the world. They have the best development practices in the world, end of story. Every single library they have has to be suitable for use in an enterprise, by definition, because that's their market. That's their market, it's enterprise. The business world runs to a large extent on Microsoft software.
That's a good point, because a lot of people, I'm kind of a Java guy, and since they were bought by Larry Ellison, I'm not sure, I think he just bought that to make money, like he's not really championing it from an enterprise.
I don't want to go there. I'm not going to make any comments about Larry Ellison.
Once you get the monopoly, then you use regulations as a tool to eliminate the little guy.
That can happen.
Yeah.
The nice thing, though, with Microsoft is their whole .NET and all their libraries, it's all open source. It's all open source.
These days, at least, used to not be that.
Oh, I used to be a Microsoft hater. Don't get me wrong. I mean, I was building big products in C++ back in the 90s, and Microsoft was the evil, just the evil, but they're not anymore. The big changes today, you can on your front end, you can use Blazor and C# even in a browser on the back end. By the way, this is kind of off topic, but it might be relevant to your point about security. Question about security. One of the reasons Node.js became so popular, right? Everybody doesn't know what Node.js is. It's basically server-side JavaScript. So that means that if you have a bunch of people that know how to build clients in JavaScript, now they could start working on the back end too. Or they could at least talk to the gals working on the back end. They both work in the same language.
That's the holy grail for management and executives.
Yeah.
Cool, 2 for 1, free, you're full stack developer.
Right, you have the ability to move people. You have ability to move people around. You have
server-side stuff. Oh, what's database? What's race conditions? What's ORM? Oh yeah, I don't know.
Yeah, exactly.
I said just take a guy from boot camp, pair him with the MIT guy, and we should be good.
Right.
Hire the MIT guy, let the boot camp guy do everything.
And the other thing I would say about that is with C# now, you can do your back end in C# and you can do your front end, so you get the same benefit. And you have the largest software in the company world pushing that. And it's all open source. And it's all free. That's a pretty good argument right there, right? So, and from a former Microsoft hater. Okay, so, yes?
I'm still on this slide. This is a totally different topic here.
Okay.
Maybe this is too long of a question, but can you give a brief overview of what goes into creating a context snippet? Like, how would you make that independent to your,
Oh, it's actually a very straightforward process. What you do is you take a piece of text, and you pass it to an encoding function, you get back a vector, and you store it in a database with a key. That's all it is. It's that simple. It's not hard. Yeah, it's not hard.
Okay, I guess. So just think how would really that's what the semantic kernel would use is just like.
Well, when you pass in a call to the service, the semantic kernel is building a prompt. When you sit down and build a prompt, what do? What's your process?
Sentence.
You just sit down and you create a question, but then you add context too, right? For instance, I've got this document, 3 pages, and I need a summary. What do? You drop it in and say, please summarize. What you dropped in is the context, and then the prompt is the action you'd like it to do. So this could be, in our example that we've run through today, could be the marketing document.
And also something to know about that key usually is that it's not like a primary key like a database, it's some kind of natural language key.
Well, it can be. It depends on the database.
Yeah, it depends on the
Redis,
database, but,
Redis doesn't do that, for instance.
A really easy way to conceptualize it is, it could be like a set of keywords that when you prompt the LLM, it'll go through the database, find the relevant keywords, and then pull in those contexts into the prompt, and then the entire prompt will be considered in context.
Exactly.
These contexts.
That's a good answer. Did that answer your question? The problem with this stuff is it's very easy to go deep. Go ahead.
Yeah, back to my previous question.
Security, yeah.
Are there any certificate in terms of security for AI blocking and stuff?
Any certificates? You mean?
Yeah, any security audit certificate?
So what I would
blocking?
do, I would look at the end user agreement for OpenAI. They actually state very clearly in their user agreement that they do not use prompts as training data.
Okay.
And I believe they also have a virtual private cloud system, so where it's still managed by OpenAI, but it's a secure network so that you can put your work-based data into it, and
Yeah.
it's segregated from the rest of the
So-
OpenAI system. Yeah.
When we talk, that's a very specific thing. That's called data security, all right, as opposed to system security. They're totally different. So in terms of data security, you're worried about, a CISO would use the term data leakage, information leakage, and you want to prevent that. So if you use an OpenAI service, what he just spoke to is they're making statements to tell you that they're not going to allow your information to leak to other people, which is fine, right? So if your context snippets contain a lot of proprietary information and you're using them in your prompts, that information is not going to be reused by somebody else. You're not giving it to anybody. I don't know if that was your question, but that's what he's talking about.
My question is really about the plugin. If it's not certified, we don't know the plugins come from where.
Okay, now you're talking about system security. And so the question, make sure that it's on the video. The question is, hey, how do I certify if I'm using a plugin that it's secure? And OpenAI does have a review process where they go through and look at submitted plugins. And it's just like submitting something to the Apple Store. It'll get reviewed, and either they'll tell you, no, you got to fix this before we'll let it go forward, or they'll just reject it. How good is that process? I have no idea. It's kind of a brand new thing, right? How big a deal is it working with somebody like Apple with mobile apps? It's a real pain in the ass. They do a good job. The bigger the pain in the ass, the better the job, I guess, right? But at the end of the day, I think you, as a business person, depending on the cost, the possible risk, have to make your own evaluation of what plugins you use. Maybe you just build them all in-house to abate the risk, because you developed all of them, right? So at one end of the spectrum, you got enough money to do that. Maybe that's a feature of your business. We only use our own plugins. At the other end of the spectrum, you want to get something out the door real quick, you use a lot of commonly available plugins, and you don't worry as much about security. It's really up to the business's needs, right? All right, so let me finish this off so that we can get to the next speaker. Tooling, future directions. In my opinion, the current tooling is pretty rudimentary. We got a long ways to go. We're at the early stage of adoption. The tooling is not spectacular. I'm a tooling guy. I've been building tools for software development for years. The next thing is that the language of prompt engineering will evolve. Right now, we don't really have a language specific to the task. Instead, we're reusing existing languages. Like a lot of things in computing science, like when Date and Cod came up with the SQL language, that was in response to a need. We need an elegant way to express queries, to get database information pulled together and returned to a user. I think prompt engineering is ripe for there'll probably be a prompt engineering language at some point. So I wouldn't be surprised to see that emerge in the next couple of years. The next thing is the breadth of available services will evolve. I think that text completion and chat completion, image generation, all these things are pretty good now, but they're going to get a lot better, right? So you can expect that to evolve. The standards will evolve. This is where you have to be careful as an adopter or as a prompt engineer, and that is that you have to understand that anything you take for granted now might just not be the way it is next week, next year, or next 5 years. So we're going to see a lot of people invest in technologies that turn out to not be there for the long run. They'll fall away and other things will emerge. That's normal with new technologies, like when databases were a new thing, lots of technology there to look at. Finally, there'll be lots of winners and losers. Try not to pay attention at least. There's not much you can do about it except place your bets where you think they might win. Yes, sir.
So just going back to that last point, so would you, from an architectural standpoint, suggest a more modular architecture that you can basically plug and play any of these different services as your organization or as they grow, as they mature? So let's say OpenAI, right? So right now you're using OpenAI as an AI services, and then maybe in 5 years it's something else. Like, should you then now, as an architectural design, say like, okay, then I can plug and play. Like if I said I want to use something else, then I can just.
Well, I would do that with any technology, regardless of whether it's this or anything else. And there are technologies like dependency injection and whatnot that make it relatively straightforward to accomplish the goal you just set out of being able to swap in a different implementation but has a common API. So if you're building a system, and part of that is going to be calling something like the semantic kernel, then you might abstract the layers so that, hey, or you have the interface. You don't like semantic kernel next year after, you want something else, you can slide it in, use the same interface, then none of your backend changes. But what about all of those things you built and the plugins? Well, plugins from OpenAI are now a standard, a proposed standard. So maybe that's the standard that wins, and all those 8 plugins you wrote are fine going forward. Who knows? I don't even think the lines dividing the different technology components that need to be swapped in and out are well defined yet, because there's loads of different approaches. So there's an architectural sort of center of gravity that we're going to move toward over time. We're not there yet. So I think you pay attention to it like any good architect would, but I don't know how much you can actually protect yourself. An example, compare databases. For a long time, the database you picked back in the old days of mini computers and stuff, that was it. You had an operand in that. It wasn't going to run anywhere else, right? And then we had the revolution of the SQL databases coming in, and then ODBC, Open Database Initiative, right? So that allowed you to have a layer and a connector. So your application can speak ODBC SQL, which was a subset of the full SQL provided by different vendors, but you could park anybody's database. You could use, SQL Server, you could use MySQL, whatever. Yeah.
That assumes that the language that these databases or that these services that they're talking about is standardized, right? Just like ODBC sort of like standardized that language for databases.
Perfect. My comment about, we're probably going to see a language around prompt engineering emerge, and it would be the same thing that they did with SQL. It'll be a mathematically derived set of axioms that drive a language definition. Sorry, that's a lot of words, and there's a lot more words behind that if you like. But when you do compiler design and you do language design and whatnot, what you're trying to do is retain a high level of flexibility, expressibility, but the ability to compile down to very different implementations is required in different platforms. So you can imagine, and I'm just guessing, there isn't one of these yet, but you can imagine a prompt engineering language that would compile down to all the different APIs provided by all the open API, other providers of AI services. Who the hell knows? I don't know. But I think we're going to move that direction.
Yes, is there, I guess, like maybe future thinking, is there a conversation right now to standardize that language?
There isn't a language like that right now. I'm just saying that.
There's this joke is there's someone who sees that there's 14 standards out there and thinks to himself, I'm going to make a standard.
That could encompass all the standards, right?
And now there's 15 standards.
Exactly.
I agree. And people say like standards.
All right, so
to me, there was that one thing that says standards is like toothbrush, right? It's like everybody agrees that you need to brush your teeth, but I'm not going to use somebody else's toothbrush.
Yeah.
why does it want to ask us on the camera? All right, so let's do the next presentation here. I don't know why it did that. Weird. Okay. Are we ready? Again, just one last thing before, where is it? There, if anybody hasn't grabbed this and wants to connect with me, just take a picture of that and then you can use it to get my LinkedIn. Coolio. Yes, sir.
Question for you in the meanwhile. Something I've seen in a lot of different cases. So using ChatTPT, I do cybersecurity consulting. So I'll say something like, I'm a publicly traded company. What should I do if I have a cybersecurity incident? It'll be like, oh, you follow the form X, parts 1 and 2. And then meanwhile, I know that this is a brand new regulation. So I'm thinking, like, how does it know about
It doesn't.
Because it says it's only current as of September 2021. And then after it gives me the answer that shows that it knows it, I'll say, tell me the SEC cybersecurity rules on disclosure. And it'll say, I don't know that. I'm only current as of 2021. It's like, you just told me.
But that's where the Snippet Contacts database comes in. So you have an opportunity where you can, either for your own use or you can make this available to others, you could take all of the current regulations and you would use your domain knowledge to take those regulations and create the snippet database, and then you would provide a service where somebody could come and they would not just get all the old up to 2021, they get all of the new stuff as well. And what you're adding as value is, and here's the most recent stuff on top of all that. Right, so you can extend what the language model understands. That's what the idea of these contextual pieces, like when I write a piece of code, it knows, maybe it knows C#, maybe it knows something about libraries. I can drop in a piece of code that's very specific, and it now knows about that when I can ask it questions. You know, what does this code do? And it can actually give me a relevant answer. You could do the same thing with security regulatory.
Well, no, I get that. I was just wondering, it did know, I know 100% sure it knew stuff that wasn't even put in play.
Well, you know what,
Yeah, it'd be hard to say. You have to look at the specific.
Yeah, I think you dive in. And by the way, there were preliminary regulations published. It probably read those, right? There's all sorts of information available out there.
I've seen that in numerous instances where it'll in an indirect way say it, and then when I directly ask it, it's like, whoa, I don't know that.
Yeah, I think Tim's right. I think it's probably that there was some mention of it in the training data somewhere.
So, Asist, are you here? Yeah, of course. So, you want to do this?
Yeah.
You got your PC primed? Sorry I ate up all your time.
Don't worry about it. This is going to be rather dense but short presentation.
Okay.
I didn't prepare a whole bunch of slides and everything.
I'm both dense and short too, so. Finally, somebody presenting off a Windows box. Or Linux, eh?
This is a computer for ants.
Can make it antsy?
So who here has heard about ChatGPT? I'm just seeing if you guys are awake, alright? Who here has heard of Hugging Face? Couple, okay. Who here has heard of Llama? Llama, okay. Who here has heard of llama.cpp? Yeah, okay. So, I guess you guys have a little bit of context, but I guess I have to fill in a couple of things. So, Llama is a large language model that was released by Facebook / Meta, whatever you want to call them today. And it is an open source competitor to ChatGPT. And it's open source not in just the sense that they released a paper and they call themselves an open company. But that the actual model weights themselves are released. And you can go to Hugging Face, and just like any of these other models, you can look right there. Llama CPP, right there. So you can actually download all 70 billion numbers that comprise this model. It's like 3 gigabytes. It's a very small model. Now, there's this really, really smart guy who sat down one day and realized, oh, hey, this Llama thing got released recently, and there is some really cool stuff that I can do with it. For one, I can make it run on a CPU. I don't need a GPU. This thing's already been trained for me. I'm not going to be doing any training. I just want to use it. And I don't have a fancy GPU, but not me, but this guy knew how to code this up. And the really cool thing is that it supports a bunch of things, and in particular, Apple Silicon. Now, I don't have an Apple Silicon computer here with me, but I am still going to demo this in just a little bit. Now, the really important and really cool part about Apple Silicon, actually, raise hands, does anybody here have one of the new Apple, like M1 or M2 laptops? Download this. try this out. Download one of the models. It is amazingly fast. Actually, here I think they even have this video. So this is a 180 billion model, 180 billion parameter model that is running. That's right. Don't have Wi-Fi here. But it's doing it really fast. It's actually doing it really fast. It's doing it on a CPU, and it's kind of magical because everybody thinks that to do these large language models you need this like super crazy hardware. But there's like a couple of people here today that have the ability to run these models pretty much at reading speed. These things do like 10 tokens a second, which is more than fast enough. So let us talk a little bit about the basics of computers. So this is like a typical computer where you got a GPU connected to the CPU, you got some RAM and SSD. And excellent. I forgot to go. Okay. So this is pretty boring. I'm sure hopefully everybody understands how this works. Now, the major limitation when you're inferencing is actually going to be right here with this GPU VRAM. Actually, this could be flipped. These could be considered one particular thing. But really, the most important thing is this interconnect right here between the GPU and the VRAM. So, the GPU is kind of like a secondary mini computer on your actual computer. It has its own RAM and it's got its own processing cores, just like how a CPU has RAM. And the really important part here is what's known as the memory bandwidth. So that's how many gigabytes a second can you transfer across this pathway right here. And that is the most important limiting factor on inference, like actually making these things run. And usually right here, this is about, 10, 20, 30 gigabytes a second. Really, really, really fast interconnect. And on my computer here, this interconnect, maybe like 4 gigabytes a second. So not great. It's kind of fast enough. I can get maybe about a token a second. Thing is that since Mac made their own new silicon, this is extremely fast. This is like 400 gigabytes a second, 800 gigabytes on the M2 Ultra Max Pro, whatever, right? So this guy sat down, he said, this memory interconnect is just as fast, if not as fast as this memory interconnect. Why don't I write the code that lets me run these large language models and ignore this part because this part is fast enough? I don't need to do the training. I just want inference. And that's actually exactly what this is saying, okay, how fast can we push the hardware that we have and actually make it run without a GPU? So this is 100% in CPU. And there's all these different models that they have hosted right here, or that it works with. And I'm going to show you a basic Llama example with it. So let me see. What I'm going to be using here, so this is CodeUp Llama 2, 13 billion chat human feedback, GGML. So GGML is the important bit. That's actually what says like, this model is compatible with CPUs. And so what I do is I come in here, I hit enter, I load this up. This is a 13 billion model. It's loading up into my RAM as we speak. Still loading up. And as soon as that is done, there you go. I am able to come in here, and there is this little chat thing. So I could use pretty much anything. There's a bunch of different chat programs, but I'm just using this one because it's easy enough. So this is actually running, and you can see there's a previous session. So I said, okay, write a Python program that reads a Parquet file from disks, compresses it with LZ4, and then writes it to disk. Spat out some code. Code is completely wrong, by the way. This code is incorrect. It pretends that there are classes and functions that just simply don't exist. But that's fine. It actually looks like Python code. It actually completely
Looks legitimate. It even explains like some stuff just like how ChatGPT would. But it's doing it all here on my actual computer. So let me see. I'm gonna ask it another question really quick. Do you guys want to maybe take bets on how long this will take? So like I said, I'm gonna ask it for about 400 tokens. It can do about a token a second. So anyone do the math on that? And then I'm just gonna ask it, could you give me a PHP function that shows the time and displays it in a green background. So let's hit enter on that. Boom, all of a sudden all my cores are going. So it's definitely running here locally. Like I said, anyone want to take bets how long this is gonna take? Minute and a half? All right, we're gonna do, what's it called, Jeopardy Rules. So if you go over, you lose, and then the closest you are, it wins. So we got a minute and a half. Anybody else? Huh? $1, yeah. Yeah, don't remember. But yeah, so as you can see, like I said, it is actually literally running this code. So this is a large language model. I'm not using a GPU here. This is all running on CPP. It is very slow right now because, like I said, I don't have Apple hardware. But if I had Apple hardware, this prompt right here take maybe about 10, 20 seconds to generate. And like I said, you can access it. These models you can download. They're not hard to get right here on Hugging Face. Where is it? See all these models. It is not hard. See these models are not too big. 5 gigabytes, 7 gigabytes, 8 gigabytes.
Well, that's really,
yeah.
One of the things you said earlier, this is open source, but
Mm-hmm.
I want to give everybody a heads up. That doesn't always mean as much as you think it means. There are two kinds of open source licenses, permissive and non-permissive.
Yep.
The Hugging Face license is non-permissive in a big way. It's one of the most restrictive open source licenses. You cannot use it for a commercial purpose. You can't even self-host it for others. So it may be open source, which means you can go and look at how they did it. You can use their model, but we can't do it for a commercial purpose. You can license it for commercial use, but then you might as well look at all the others as well. Just so you know, open source is not always free.
Yeah, I think if there can be differences in the licenses, because I think Hugging. Well, I thought with Hugging Face you can upload it under like Apache or whatever, or is it all models? I didn't know that.
Well, they just looked at the Pilot General license.
Yeah.
But I mean, it's still, it could be used lots of different ways. I mean, if you were doing something completely in-house, like just for your business, and you weren't going outside, you might be able to use it.
Yeah, absolutely. Or if you had like very significant security concerns, that kind of stuff, you could just download these models, have them run locally. Now, this is a 13 billion model, and I chose it because I only have about 32 gigabytes of RAM, but you could easily pick larger models and even go up to like a 70 billion model, and those. No, it's an AMD something. Thread or Ryzen 5. Yeah.
While this is running,
yeah.
Can you refresh my memory? What is a token when you say that? What does that mean?
So a token is a subword. So like SH would be a token. Space would be a token. EA, so a word is composed of usually 2, 3, 4, 5 tokens. And it's a way to compress. Rather than having each letter be a token, you have pairs or triplets of commonly used letters together as a single token. And how that's determined is that they take a corpus and they run basically like a compression algorithm to see like the relative occurrence of like these doublets or triplets of letters. And they just take like the top and most common triplets or doublets of letters, and they just stuff them into a database. And then there's like a little tokenizer program.
Yeah, that's one of about 8 different way.
Yeah, I'm oversimplifying.
So, and it was well said the way it said.
Yeah.
But the idea is that we need to take text to numbers.
Yeah.
You need an encoding scheme. There are, like I said, 8 different ways of doing it. And some of those are actually using neural nets to generate the weights, the numbers
Yeah.
to the tokens.
Yeah.
So there's loads of different ways of doing it. Essentially, though, you're just going from text to, instead of words, you have numbers. When you go the other direction, you can take numbers that have been generated, which is the LLM does, and they decode it.
Yeah, it's a one-to-one. Yeah, it's a one-to-one function. Yeah.
All this stuff going on in the background is all numbers.
This is really one important low-level question. Like, is it basically key value pairs, kind of?
No, they're vector.
No, it is a map. It is a bijective.
Words, but the encoding process takes the text and encodes it as a number, or it takes a number and decodes it into text.
Yeah.
The methodology underneath there can be all sorts of different technical implications. Key value pairs are not really what's going on here.
Yeah. I mean, it is a bijective map, so it's a one-to-one relationship, but other than that, it's not really a map. But yeah, so like I was saying, my CPU RAM connection, not very fast. But the people with MacBooks, this is their gig, because.
People with GPUs can just.
Or yes, people with GPUs. But I just wanted to show people that you don't need a GPU. All you need is maybe a fancy MacBook or a reasonably modestly sized GPU. What you can get a 4090 these days for $1,500. That's not.
Yeah, you gotta justify it to your wife.
Yeah, well, actually, what I would strongly suggest, rather than you guys going out and buying GPUs, Vast AI, Lambda Labs, there's a number of places that you can actually rent GPUs for pennies on the dollar. I can go rent an A400 GPU, this is a $5,000 GPU, for 40 cents an hour. It's insane how cheap it is. It actually just almost does not make sense for people to go out and buy these GPUs if they're going to go do it themselves. Just go on Vast AI or go on Lambda Labs and just rent a box.
Well, the
and
cloud
just
providers, AWS, GCP, and Azure all offer it as well.
yeah. I'm just saying at a pricing point, Vast and Lambda's a little bit better. But yeah, AWS, GCP, Azure, they all have it. So. But I just wanted to show you, what's possible with these small boxes. And hey, okay, it looks like we're done here. And let's see how well, certainly. Oh, hey, there, that actually looks pretty good. It kind of cut off a little bit, but yeah. Show time in green, here's the date, and then echo that, and if you finish that off, I mean, that looks like PHP code to me, Now, like I said, this is a 7 billion parameter model. I chose a smaller model because it can fit on my computer. If you wanted to do something actually interesting with these models, you'd probably want a larger model, like one of the like the 100 billion models or anything like that. So,
are the smaller models just quantized versions of the larger models?
So all of these models are quantized. So for it to so even the larger ones, for it to run on the CPU, they quantize all of them. So this is actually a really good article that kind of goes into this a little bit more. But here's the approximate size. So like I said, I'm running this little 13 billion model, and I'm running it with the 4. So this is the quantization. So you got 4-bit quantization, 8-bit quantization, 16 and 32-bit quantization, and then how much RAM you need. So, for this small little model, I only need about 7 gigabytes of RAM. But if I wanted to go really crazy and maybe go with a 65 gigabyte, even still, I could pretty much fit that into my RAM. Not quite. And then the other thing that you should need to know about is that the inference time is linear. So with a lot of older neural networks and that kind of stuff, the bigger the model got, sometimes the longer and longer it would take. If you got a 2x size model, it would take maybe 4x longer. The nice thing is transformers are not like that. They actually linearly scale. So if you look at this, the bigger the model, you just double it. So if I have a 7 gig model and then I want to use the 8-bit quantization, it'll take twice as much RAM and it'll take twice as much inference time. It's just a linear scaling with the amount of RAM space you need to take and the amount of time it takes. And one sec. And then this is like the actual inference time. So this is an A100. An A100 is, I believe, a $25,000 GPU. Way more expensive than any of the kind of GPUs we would want to. Yeah, these are server grade GPUs. But again, this is kind of just another chart that's comparing like, oh, okay, we have the same number of parameters, we have the same quantization. How many milliseconds is it going to take to do one round of inference? And that's like inferencing one token. And so as you can see, it works really quickly. And this is actually not all that far off from right here with the MacBook Air. So see, it has a memory bandwidth of about 70 gigabytes with 5.5 teraflops of F16 compute. And then here you go, M Pro has 200 gigabytes, 400 gigabytes a second. So that's the main limiting factor is what I was talking about here, where this part, this memory bandwidth, how many gigabytes a second it can transfer is going to be really, really important. And if it's really fast, you get fast results. Mine, it's about 10 times slower, so I get 10 times slower results, but I can still show it to you.
So number, you're getting like 400 gigabytes per second on the main CPU with the Mac?
Yeah.
And what about a good GPU VRAM?
About a terabyte.
So about double?
Yeah, about double. Yeah, but that's what I'm kind of trying to point out to you guys.
There's one more aspect, though,
Yeah.
and is that you still have to move the models from RAM into the GPU, and if the amount of
Yeah.
GPU memory is under
The model size.
swapping it, you'll end up with the link less memory space.
Yeah, exactly. So this connection will get overloaded. So if it fits all of it into RAM, then it'll work really fast. But if the VRAM is smaller than your model, it'll actually do this all over and over again, and it slows down significantly. So, but what I'm trying to point out is that on the Macs at least, this part is pretty much just as fast as this part. And if you're not doing training or you need a whole bunch of compute to do to create one of these models, you just want to use one of these models or even just fine tune one of these models, you can do that all on the CPU and all on RAM. You don't need a fancy GPU.
With Macs, though,
Yeah.
Most of them have limited amounts of main RAM available.
Yeah.
In other words, you can't get 120 gigs.
Unless you get a workstation, yeah.
Yeah, you need it on a workstation.
Yeah.
Even then,
Is re-changing to M3, but it's very sweet.
Yeah.
yeah.
Yeah, exactly. So, I mean, I've never been very excited about Macs and that kind of stuff, but seeing the numbers and seeing how quick this stuff is, I've strongly considered buying a MacBook just because that memory bandwidth speed is important for not just inferencing of LLMs, but pretty much any kind of data application. I mean, if you're doing any kind of moving around, yeah, that stuff, it works. It's so important for that stuff to be fast. And Apple making their own silicon and focusing on making that stuff fast has provided a kind of value offering that just none of the other CPU manufacturers can provide. And like I said, it shows up in like a 10% performance increase with these LLMs over regular hardware. And opens up a whole bunch of more research. So that's my talk.
Yeah, I'm sorry we didn't give you more time.
No, it's fine. It's fine.
So it's a little after noon, so I didn't want to keep everybody away from watching Chris's buffet. Good food. Any last questions before we close it up? Nope.
All right.
Thank you both.
Thank you.